Hello everyone. Okay, so we are going to be doing algebraic expressions, or not algebraic expressions, apologies, algebraic identities today. So, what's an algebraic identity? Algebraic identity is essentially when we have two polynomials equal to each other, and just the coefficients of like terms must be equal to each other. So we're going to be comparing coefficients. So for example, so note here, when we have two polynomials equal to each other, the coefficient of the like terms must be equal as well. So for example, if I have ax plus b is equal to 3x plus 7, right? I'm going to have 3x is equal to ax, a is equal to 3, and then b has to equal 7 because they don't have the x term in them. The same goes for binomials, trinomials, polynomials sort of degree 4, etc., etc., etc. So let's have a look here. I have 3t squared x plus c, or minus 3px plus c minus 2t cubed equals 0. And then I want to find c in terms of p. That's the really important thing in this question. I want to find c in terms of p. So how do we do this? Well, I know it's equals 0. So I'm going to rewrite that now because I don't have the x's on my right hand side. So I'm just going to rewrite my right hand side as, I'm going to write that as 0x plus 0. I'm going to rewrite it like that. Now, I'm going to gather and factor out any my x's here. I'm going to gather and equate my like terms. So I see here I have 3t squared x minus 3px. I'm going to factor out an x there. So I have 3t squared minus 3p times x plus c minus 2t cubed is equal to 0x plus 0. So I'm going to equate my coefficients here. So my coefficient of, right, my coefficient of x is 0. So therefore, 3t squared minus 3p has to equal 0, right? Because these coefficients have to equal to each other. So I have 3t squared is equal to 3p. I have t squared is equal to p. T is equal to square root p. My answer is square root of p. Then, likewise here, right, this c minus 2t cubed, that has to equal 0 as well. So I have c is equal to 2t cubed. But what's asking me for up here? It's asking me for c in terms of p. But I have c in terms of t. But looky here, I have t in terms of p. So if I sub this in here, I'll get c is equal to 2 times root p to the power of 3. Now just recall, root p is the same as p to the power of a half. So I have 2 times p to the power of a half to the power of 3. A power to a power I multiply, so it'll be 2p to the power of 3 over 2. And that is what c is equal to. So that's more or less what the questions kind of are asking us to do. So let's look at this one here. In the expansion, 2x plus 1 times x squared plus px plus 4, where p is a natural number, that seems really important. The coefficient of x is twice the coefficient of x squared. Find the value of p. So let's do this. Let's multiply out my bracket. I have 2x times x squared plus px plus 4 plus 1 times x squared plus px plus 4. 2x cubed plus 2px squared plus 8x plus 1 times x squared is x squared, 1 times px is px, and 1 times 4 is 4. Gather my like terms here, 2x cubed. Now, I'm going to gather my x squareds here. So 2px squared plus x squared. I'm going to factor out an x squared between them. And I'm going to be left with 2p plus 1 x squared. And I'm going to do the exact same thing with my x's here. So I have 8x and then I have px. Sorry, that looks a bit poo-poo. Let me fix that. Px. Right? And then I'm going to factor out an x here. And I'm going to be left with 8 plus p x plus 4. Now, if we read the question again, the coefficient of x is twice the coefficient of x squared. So this is my coefficient of x. So 8 plus p is twice the amount of the coefficient of x squared, which is this. So 8p is going to be equal to 2 times 2p plus 1. So I have 8 plus p is equal to 4p plus 2. and I'm going to have 8 minus 2 is equal to 4p minus 1. 6 is equal to 3p. I'm going to have p is equal to 2, and p is a natural number, so I know I'm right, and I can go and tick it off for myself. Let's look at this one here. Find the real numbers a and b such that x squared plus 4x minus 6 is equal to x plus a all to be squared plus b for all x and elements of real numbers. So x can be a fraction, x can be 0.3578, x can be any number we want. So I'm going to multiply this expression out. So I have 3. So I have x squared plus 4x minus 6. If you're watching this video later in 6th year, this is completing the square. But, you know, don't have to worry about that. That's Algebra 3. Anyway, it's later. We're doing it my way. We're doing it this way. X squared plus 2ax plus a squared plus b. So, just to note, this is a perfect square. That's a perfect square, so I just multiply it out quickly within my head. So gather my like terms, x squared, no information really to be told, so I'm just going to leave that for the minute. For x, I have a 2ax here, so let's equate them. 4x is equal to 2ax, so 4 is going to be equal to 2a. A has to equal to 2, right? Okay, so I have something there, and let's look at my final one here. I have this minus 6. Well, that minus 6 has to be equal to a squared plus b because they don't have the x term, so the constants on the left hand side have to equal the constants on the right hand side. So I have minus 6 is equal to a squared plus b. I know what a is. A is 2. So I have minus 6 is equal to 4 plus b. B is going to equal to minus 10, and that is my correct answer there. So a is equal to 2, b is equal to minus 10. The next section we have here is partial fractions. So partial fractions, a partial fraction is just a sum of two fractions, really. But we just don't know what the two fractions are. But literally, right, it's the exact same process. You're adding the two fractions together, but in this case, you're just going to equate the numerators. So I did the heavy work for you here. So I found a common denominator. So I have 1 over x plus 1 times x minus 2 is equal to a over x plus 1 plus b over x minus 2. So I want to find the values for a and b. So I have this fraction now on my right hand side. And my left hand side is equal to 1 over x plus 1, x minus 2. And that is going to be equal to, so these are the same denominator now. So I'm going to have a times x minus 2 plus b times x plus 1 all over x plus 1, x minus 2. Now again, we just kind of equate things. So I'm going to equate the numerators. So I'm going to have 1 is equal to a x minus 2a plus bx minus, what was that one? Plus b. So I don't have any x's on my left hand side, so I have no x's. I'm just going to put in a 0x. I'm just going to put in a little 0x to help remind me what I'm doing. So now let's gather some terms. So I have 0x, ax, bx. So ax plus bx equals 0. So a plus bx is equal to 0. A plus b equals 0. A is equal to minus b. Again, this doesn't tell me much information, but let me circle it and get back to it. Now my second one here, my constants have to equal to each other. So I have 1 is equal to minus 2a plus b. So 1 is equal to minus 2a plus b. I know what a is from my previous example here. So a is equal to minus b. So I have 1 is equal to minus 2 times minus b plus b. 1 is equal to 2b plus b. 1 is equal to 3b. B is equal to 1/3. Right? And if b is equal to 1/3, therefore a has to equal minus 1/3 because a is equal to minus b. So let's do 2 more examples of that, and it'll be very much the same really. So I have 1 all over x minus 3, x plus 4. So if you recall about adding fractions, this fraction added together would be a times x plus 4 plus b times x minus 3 all over x minus 3 times x plus 4. Again, equate coefficients. So 1 is equal, so the numerators are equal to each other. So I have 1 is equal to ax plus 4a plus bx minus 3b. So I have no x on my left hand side, so I'm just going to add in a 0x to help me visualize better. So 0x, ax, bx. So I'm going to have b plus a x is equal to 0x, so I factor out the x between them. I have b plus a is equal to 0, b is going to equal to minus a. Again, that doesn't provide much information, but let me just circle and get back to it. Over here, now, I'm going to have 1 is equal to 4a minus 3b. Well, I have b is equal to minus a, so let's just use that. 1 is equal to 4a minus 3 times minus a. 1 is equal to 4a plus 3a. 1 is equal to 7a. A is going to equal 1 over 7. And therefore, if a is equal to 1 over 7, b is equal to minus a. So b is going to equal to minus 1 over 7. And they are my final answers there. And let's look at this example. Again, the exact same things happening here. It's going to be 1 all over x plus 2 times x minus 5 equals p times x minus 5 plus q times x plus 2 all over x plus 2 x minus 5. Equate the numerators. 1 is equal to all this. So 1 is equal to px minus 5p plus qx plus 2q. Again, I don't have x's on my left hand side, so I'm going to add in a x to help me equate things. So I'm going to equate my things here. So I have 0x, px, qx. So I'm going to factor out the x here between these two terms, and I'm going to be left with p plus q. X is equal 0x. P plus q has to equal 0. So p is equal to minus q. Again, the exact same thing is happening. P is equal to minus q. Now I'm going to sub it in. Not sub it in yet. I'm going to have 1 is equal to minus 5p plus 2q. Therefore, I have 1 has to equal p is equal to minus q. So minus 5 times minus q plus 2q. And then that is going to break down to 1 is equal to 5q plus 2q. 1 is equal to 7q. Q then has to equal 1 over 7. And if q equals 1 over 7, p is equal to minus q. So therefore, p has to equal minus 1 over 7. So there you go. Just be careful, because I know these examples worked out to be nice, where one was positive, one was negative. That mightn't always be the case. So don't be too presumptuous, you know? Right. And then finally, the last section we have here is problems involving factors. So we have two ways to do these questions. So we have the division method, and we have our multiplying by general term, and then equating coefficients. So the problems with factors. So if you see a question where it says blah 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 is a factor of blah 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 blah, and it might say find the other factor, or it might say prove that blank blank blank. So that's when you're going to use one of these methods. So I'm going to do both of them now to this example here. You know what, let me just rub this out so I can just rub it out here. So method 1, this is going to be my division method. 3x squared minus 11x plus or is a factor of 3x squared minus 14x plus 17 minus or. Find the value of or. So if this is a factor of this, that means when I divide it in, I should get 0, right? So I should get divides in perfectly. So I'm going to have 3x squared minus 11x plus or. Dividing that in now to 3x cubed minus 14x squared plus 17x minus or. So my first thing is 3x cubed divided by 3x squared is equal to x. So put that on top. x times 3x squared is 3x cubed. X times minus 11x is minus 11x squared. You know the drill. Take away the signs. Minus, that minus becomes a plus. So 0 minus 14x plus 11x is minus 3x squared. Bring down this plus 17 plus 17x. Second one, minus 3x squared all over. I'm dividing that by 3x squared. Minus 1. Right, minus 1 like that is minus 3x squared. Minus 1. Oh, sorry, and then I had this x times or up here. Did it? Right, so let's look at an example here. So if 3x squared minus 11x plus or is a factor of 3x squared minus 14x squared plus 17x plus minus or, find the value of or. So this polynomial here is a factor of the other polynomial. That means it divides in evenly. That means if I divide it in, I should be left with a remainder 0. So I have 3x squared minus 11x plus or. I'm going to divide this in now to 3x cubed minus 14x squared plus 17x minus or. So 3x cubed divided by 3x squared equals x. So I'm going to put that on top. X times 3x squared, 3x cubed. X times minus 11x minus 11x squared. X times or is plus or x. So now I'm going to change the signs. Minus plus, this is going to go to a minus. So I have 0. Minus 14x plus 11x is minus 3x squared. And then I'm going to have here 17x minus or x. I'm going to make this one term by factorizing, just to make it easier for myself. I'm going to factor out the x, and I'm going to be left with 17 minus or x. And then now I bring down my remaining term. Then first term minus 3x squared divided by 3x squared. That is going to be equal to minus 1. Put that on top. Minus 1 times 3x squared is minus 3x squared. Minus 1 times 11x is plus 11x. Minus 1 times or is minus or. So we're going to change the signs and add. Plus, minus, plus. So minus 3x squared plus 3x squared, that goes to 0. This 17 minus or x minus 11x has to go to 0. That has to equal 0 because that will remain 0. And then minus or plus or goes to 0. So now we form this equation here. 17 minus or x minus 11x equals 0. So I'm going to have 17x minus or x minus 11x equals 0. I'm going to have 6x minus or x equals 0. I'm going to have 6x is equal to or x. Therefore, or is going to equal to 6. So, or equals 6 in this case. And then you can always check it by putting in that answer there as well. Now, method 2. Right, method 2 involves multiplying by a missing factor. Usually, you're only ever really adding in one factor. But you might be asked to add maybe 2. So what you do for the second method is you multiply the general terms and equate coefficients. So first you find the missing factor and you multiply the factor and equate coefficients. So if I have, let's say, this is a quadratic is a factor of a cubic. This has 2 roots. This has 3 roots. So I need to now multiply with something that has 1 root in order to be 3 roots. And that's why I multiply by ax plus b. Now it doesn't need to be a and b. You can literally use whatever you want. If a and b is already in the question, use m and n. Use L and p. Use W and Z, like W, whatever, I don't really care. So we're going to multiply now 3x squared minus 11x plus or by ax plus b. So 3x squared plus 11x, no, minus 11x, scusi, plus or. I'm going to multiply that by ax plus b. And then I'm going to equate the coefficients. Then my coefficients here, my right hand side is 3x cubed minus 14x squared plus 17x minus or. So I'm going to have here ax times 3x squared is 3ax cubed. Ax times 11 minus 11x is a minus 11ax squared. Ax times or is plus or ax. B times 3x squared, that is plus 3bx squared. B times minus 11 is minus 11bx. And then b times or is plus or b. Now, that has to equal this equation. So let's equate coefficients here. So 3ax cubed, 3x cubed. So equate them. 3a has to equal 3. So I'm equating the coefficients. A is going to equal to 1. Okay, not a lot of information, but it might help us. Now let's equate my x squareds. So I have minus 11ax plus 3b, sorry, 11ax squared plus 3bx squared. So minus 11ax squared plus 3bx squared. Take out my x squared, minus 11a plus 3b x squared. That has to equal to minus 14x squared. So therefore, minus 11a plus 3b has to equal minus 14. Well, look, I know what a is. So minus 11 times 1, which is this 11, plus 3b is equal to minus 14. 3b is equal to minus 14 plus 11. 3b is equal to minus 3. B is equal to minus 1. Okay, not a lot of information again, but we move. So we're looking for or. So let's keep going. Let's keep on trucking. So I now have or ax minus 11bx. That has to equal 17x. Okay, now I'm dealing with the ors. Now that might help me with something. So I have or ax minus 11bx is equal to 17x. Factor out the x here. I have or a minus 11b all times by x is equal to 17x. So that means all of this has to equal 17. So or a minus 11b is equal to 17. But I know what a and b are. So or times 1 minus 11 times 1 minus 1, I should say, is equal to 17. Or minus 11, or plus 11 is equal to 17. Or is going to equal to 6. And that is the answer I got in the previous question. So it's up to you guys, really, if you want to use division or the missing factor method. So for these questions, for these two questions, I'm going to do the first one, the division method. And then for the second one, I'm going to try and do the missing term method. Right. Right, so let's look at this question. So this is from the 2008 Leading Cert paper 2, question 1. So I'm going to use the division method for this one, and then in the other question, I'm going to use the factor method. So 2 roots of the equation ax cubed plus bx squared plus cx plus d is equal to 0. So they are p and minus p. So x plus p and x minus p are roots of this equation. So therefore, x squared minus p squared is a factor of this equation. So if I divide x squared minus p squared into ax cubed plus bx squared plus cx plus d, I should be able to get something that allows me to get down to this. So let's multiply it in, or divide in, I should say. So ax cubed plus bx squared plus cx plus d. Right, so 1, going to do my division. So ax cubed divided by x squared is ax. So put ax on top. Ax times x is ax cubed. Ax times minus p squared is going to be minus p squared ax. So minus plus, I have nothing here for the x squareds. So that's going to be 0 plus bx squared plus cx minus p squared ax. Now, before we do anything else, see this, I have two x terms. Ugh, I really like that. So I'm going to factor out an x, px squared. So I'm going to do c minus p squared ax. Now I'm going to bring down this d. Now I'm going to do my division again. So bx squared, this is my last now term here. So bx squared divided by x squared is b. So there's my missing factor on top there, ax plus b. B times x squared is bx squared. B times minus p squared is minus pb squared. bp squared, I should say. And yep, that's it. So I'm going to have here, change the signs, minus, plus. So this is actually a constant term. So I'm going to bring it over to my d here. So this all has to go to 0, right? That goes to 0 grand. So c minus p squared ax. Oh, I have no x's here, right? So that means this has to equal 0 because this, I have no x's. This is going to be nothing. So my first equation here is going to be c minus p squared a equals 0. And then I'm going to have c is equal to p squared a. Okay, let's see if I can need to do anything else with that. Then my second equation I have here is this one, d minus bp squared, right? D minus bp squared, that has to equal 0 as well. So I'm going to have d is equal to bp squared. So what I am looking for here is I am looking for BC, right, and AD. I want to get rid of my p's. So what I'm going to do is I'm going to isolate p squared in one of these equations. So I'm going to have c over a equals p squared. And I'm going to do the same here. I'm going to have d over b is equal to p squared. Now, I have these two expressions, both in terms of p squared, so I'm going to let them equal each other. So c over a equals d over b. I'm going to cross multiply, so I'm going to multiply across by ab, and then I'm going to have bc is equal to ad, and that was what they were asking me initially. So bada boom, bada bing. I've done it out there, and that's how you can do it with division. I think you are more than, it's easier this way to multiply by a common by a missing factor, but you could try that one for yourselves. Here, x squared minus t is a factor of x cubed minus px squared minus qx plus or. Show that pq is equal to or. So I'm going to use my adding missing factor weights. This came from 2006. The Leading Cert High Level paper from 2006 is paper 2, question 1c. So I'm going to multiply x squared minus t. I'm going to multiply that by ax plus b, right? Because this is going to have two roots. This is a quadratic. So I'm going to multiply it by something with one root, because then that will equal a cubic. So x cubed minus px squared minus qx plus or. Going to multiply this out. X squared times ax is ax cubed. X squared times b plus bx squared minus t times ax minus tax minus t times b is minus tb. That is going to equal x cubed minus px squared minus qx plus or. Now equate coefficients. So ax cubed, x cubed. So ax cubed equals x cubed. So a is going to equal to 1. Okay, that might help me now in a minute. Let's equate my x squareds. I don't have any other x squareds. So I have this bx squared here. Let me do a different color. I have this bx squared. That is going to equal minus px squared. So bx squared is equal to minus px squared. Therefore, b is equal to minus p. Okay, so not what quite I'm looking for. I'm looking for PQ is equal to or. So I don't need any A's or B's or anything yet. So let's keep going. Let's look at my x terms. So I have minus TAX is equal to minus QX. Minus TAX is equal to minus QX. Then I'm going to have minus TA is equal to minus Q. I know A is equal to 1, so I have minus T is equal to minus Q. T is going to equal to Q. Okay, again, nothing really that helps, but it might help me in a minute. Then let's look at my last one here. Let's create my constants. Minus TB is equal to OR. Okay, now I'm getting my ORs in. Grand. TB equals OR. Well, let's look what I have. Well, T is equal to Q, so minus Q times, and B is equal to minus P is equal to OR. Minus Q times minus P is going to be equal to PQ is equal to OR. And that is what they were asking us in this problem. So, and that's what they're asking us in that problem there. Were they asking us? Okay. So, next part here, express the roots of this polynomial in terms of P and Q. So we want to express the roots in terms of P and Q. So I have here x squared minus t. So that's going to be x squared minus t is equal to q. So x squared minus q. And then the other root here is ax plus b. Well, a is equal to 1. So I have a 1 times x is 1x. And then plus b is going to be minus p. And then they're asking me to get the root, so I'm solving these. So now I'm going to let, this is a bit of algebra too. So then I have x squared is minus q is equal to 0. So it's kind of like solving quadratic. If I have two brackets equal to 0, I just let each bracket equal 0. So I'm going to have x squared is equal to q. So x is going to equal plus or minus the square root of q. So there's two solutions. I need 3 solutions for a cubic for the roots of a cubic equation. Again, that's what I'm going to do in algebra 2 called the fundamental theorem, algebra theorem or something. I don't know. I'm tired. Leave me alone. And then I have x minus p equals 0. X is equal to p. Right? So there are all my roots of this equation. Right, and that's it for this video. I hope it was some help. I'm absolutely exhausted. I think I bombed through that, but sure luck. And I'll catch you guys later. Okay, bye.